required in data science. Yesterday, some of the speakers mentioned that knowledge of statistics is very important to be good in data science. So he will introduce you to the basic concepts that are actually significant for this. Professor Shalabh is a professor in Department of Mathematics and Statistics in IIT Kanpur. His specializations are statistics and econometrics. He has been conferred with IISA Young Researcher Award, National Award for Young Statisticians, and
Oh,
many
Ranjana,
other
Ranjana,
awards.
Ranjana, don't worry,
Yes.
don't worry, don't worry, don't worry.
He is author of 3 books and many papers. Professor Shalabh, I'm happy to have you with us. Please continue.
Yeah, thank you, Ranjana. Thanks a lot. Okay, first tell me, can you see my screen or not so that I can make my things clear first?
Yes, your PPT is visible.
Okay, sure, sure. Okay. So the first question comes to all of you. That is a big question that what is this data science? Means if you try to see a couple of years back, nobody knew about these topics. And even if you ask me, means I was trained in mathematical statistics. And nowadays, nobody wants to do the same statistics, but everybody wants to do the data science. So the first biggest question comes, or a confusion rather comes, means among many of you, that what is the basic difference between statistics and data science? And well, this experience means I came to know, or I understood about this different through two projects which I was doing recently with the Ministry of Defense and one with the this police department. And there I understood that what is the basic difference between the training as a statistician and as a data scientist. And you have to understand one thing, means if you say data science, what do you really mean? Do you mean only statistics? Not really. There is a contribution of statistics, mathematics, computer science, and plus something more. Something more is going to come from the area in which you really want to work. For example, and if I try to think that how this change happened, means possibly means I am one among those who have seen the change. Means at this moment the new young generation cannot believe on my words, but the computers started coming to India sometime around in 90s, and at that time I was a student. I was doing my masters. So believe me, in fact, I had touched the computer for the first time after doing MSc. And then there used to be the first computer which did not had any RAM or hard disk. There were only 2 floppy drives, and we used to work on those things. And I think the floppy size was 512 kilobytes. Right, so nobody even thinks of a kilobyte nowadays. And then gradually this development happened, and computers started developing, and then yeah, then came Pentium 1, Pentium 2, Pentium 3, Pentium 4, etc. And after that, the progress became really exceptionally exponential. On the other hand, we as a student, we were trained in theory. At that time, there used to be at the max some scientific calculators, not beyond that. So whenever we were taught the theory, we were taught only the, or whenever we were taught the statistics, we were taught the statistics from the theory point of view, mathematical point of view. So, and whenever we will ask for that, okay, how are you going to apply? Then then uh, the uh, the reply was extremely simple. Well, this is the formula for the X bar sample mean. And if you have the data, you can very easily compute the sample mean by summing up all the observation and dividing it by the number of observations. And the same reply was continued in all the topics, either it is a simulation based course or say anything else. And whenever we will ask for the data, means getting a data of size 10, 20, 30 was even a big deal. So this is how we learned statistics. But now parallelly what happened, that computers started working and their growth became good, and then there was a development of the statistical package. These packages came before me, and I remember that how we learned all those things. So in fact, at that time, the capability of the package was also extremely low, and gradually it increased, and the packages like SAS and other things, they became very popular because they can handle a large amount of data. But the large amount of the data was something like say 1000 values, 2000 values, and we used to be very happy. Now, then came this cell phones. Cell phone started doing a great thing in the data collection. Means you can imagine that at the moment, most of the people in the world, in this country, are using cell phone. And practically the data has become so cheap that anybody can really afford it very easily. But now what's really happening? All our movements, what we are doing, they are getting transmitted to some agency. Believe me, when I started working or entering into this data science, then I understood that technology also. The technology has become so quick, and we don't think about those steps which we want to take or not. Right. For example, if I say all of you must have installed some Google application. So this Google application is always transmitting the information from your phone, from your surroundings to some data server. Means how do you think that if you want to go from one place to another place, Google Map can give you the answer in couple of or say fraction of seconds? That means lots of information is getting transmitted from all the phones, and those phones are becoming as a server. So you can imagine that millions and billions of and trillions of people are transmitting the data every second to the Google server, and that data is getting stored there, and data is getting say analyzed, and based on that you get an outcome that if you want to travel from here to some other place, what's the route and how much time are you going to take. Now you can see finding out the distance between 2 points that you have learned from your class 7 or class 8, and possibly that is the same technology which Google is also using, that how to find out the distance between 2 points. Well, in this case the distance is not going to be straight line, but some algorithm has to be used. Now, in case if I give you some data, and if I give you the same algorithm, or I give you a couple of algorithm and give you some data, possibly you can choose very easily that which of the algorithm is going to give you the correct information. But now, when millions and billions and trillions of people are giving you data and algorithm, and they want the answer in a fraction of second, you cannot do it manually. Then you have to take the help of some computers, algorithm, computing technologies, etc. But the concept, the methodology, the approach by which you are going to find out the distance between the 2 points, that is going to be the same. And now another question comes here, means every route will have some random variation also. Some route may have traffic at the moment, but after say 5 minutes, the traffic may get changed. So this type of prior information and the data uncertainties will always be there in the data. So now in order to calculate the distance between the 2 point and the time taken in traveling from one point to another point, we also have to take care of some random variation. And that is how this, instead of mathematics, the statistics comes into picture, because the statistics can handle the randomness, whereas mathematics cannot handle the randomness. So now the scenario becomes very simple. There are millions and billions of people. They want to travel from one place to another place, and some data has to be collected immediately. and immediately that data has to be analyzed, and immediately the user has to be told about the outcome. Now, these things cannot be done manually. So we have to take the help of some computer science tools, and some logic and artificial intelligence also, which can take care of some common sense thing. Means for me, artificial intelligence is complete the programmed version of your natural intelligence. And whenever we are trying to travel on a route and suddenly if we see that there is a traffic jam, we just avoid the route and we take alternative route. So this is my natural intelligence that is converted into artificial intelligence through programming. So this artificial intelligence, computer science, statistical tool, optimization methods, they all came together and they created this data science. This is my personal opinion, and I personally feel that this is how the data science has been created. But initially, when this data science was created, people like me who are working in statistics, they are getting their bread and butter from statistics. They got scared that, okay, possibly now I'm going to lose my job, or possibly I may lose my importance. But believe me, when I did my MSc in statistics, I was just praying to God, God, just give me a small job. I will be very happy and I will not ask anything. And nobody could at that age think that this statistics is going to be converted into data science, and people will not allow you to sleep in the night because, yeah, they expect many things from you. So this is how means statistics got converted into data science, and now we have to think in terms of data science because this is a need of the time. But definitely the importance of a statistician and statistics has not become less, but it has increased manyfold, because whatever you want to do without using the statistical tool, you cannot do it. And then whatever you want to do, that has to be based on some statistical theory, statistical knowledge. Because otherwise, whatever you are trying to compute through some statistical tool, your conclusions will not remain actually valid. That is the main issue. So that is why the theory of statistics started playing very important role. And believe me, nowadays, when we are talking of big data analysis, we are falling short of the mathematical knowledge to solve the problem. The problems are so many. We are unable to solve. Believe me, the subjects like topology, they have become very important, because now when I want to do the data analysis in a big data, possibly topology is the appears to be the only way out at the moment. So now this is how the things are changing, and they are becoming more knowledge based. But what is happening if you means go on internet, means everybody is trying to teach data science. Every institute here and there is trying to offer a course in data science. But I can promise you, I can challenge you all openly that how many of you really understand data science, and how many of you really have a good background to understand or teach the data science. Because I personally feel that when you are trying to teach the data science, you should have some people from statistics, mathematics, computer science, and some allied sciences in which the application is there. Now, the thing is this, unless and until you sit together, you cannot have a successful program. And well, I'm saying this thing, it is not in the sky, because at IIT Kanpur, we are trying to float a program on the BSc in data science from the next semester, and the selections are going to be through JEE possibly. So now we are struggling with all these things, and yeah, that gave me a surprise that even at sitting at IIT Kanpur, we are not satisfied that the type of things what we are doing in data science, they are really data science, unless and until we invite the people from different disciplines to join the program. So that is your data science. So when I say data science, I'm not saying that statistics is the only thing which is the root, which is the fundamental. No, you have to give equal respect and equal importance to statistics, mathematics, computer science, and different types of allied sciences. Right. So this is how, this is the background of what is the difference between statistics and data science. Well, so my objective in the next 3 hours will simply be Just to give you the statistics basic fundamental, which I feel that may be useful from the data science point of view. Well, when you come to data science, you have two options. Either you try to use very simple tool or you try to use very complicated tool, approximate tool, or say the tools in which you are not certain, they are not really going to help. Right. So let me now begin this lecture. I hope if you have any question, you can just stop me at any time. Right. So that's all. Okay. So now can you see in this screen what you can see? This is just data, data, and data. And you can imagine that this data is going to be in, say, what numbers, right? At this time, the big data is not your megabyte or kilobyte or gigabyte. The big data is going
Mr.
into
Vikas, do you
petabyte.
have any question? Mr.
Yes, ma'am.
Vikas,
I do
raise your
have,
hand.
yeah, I do have 2 or 3 questions actually at this point of time.
Sure, 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 please.
So, sir, my first question is, since the data is residing on the computers since 2000 actually, when the modernization or the revolution has started actually. So, why we are considering the data science as an important aspect right now in 21st century, like in 2020? Why
Yeah.
the people were not much focused towards data earlier times? This is my first question.
Yeah, actually, the fact is this, because I have a very simple question. 15 years back, had you thought that there will be a time when using your cell phone you can book your air tickets, or you can the electricity bill? Means getting a phone connection used to take 10 to 12 years. So the technological changes which has happened in the last 15 years, I think as a human being, nobody thought about them. Means I have seen that era because means in early 90s when we had the first telephone connection at our home, it used say about 7 years to get the connection because my father had paid the fees in US dollars.
Yeah, got it.
If you
Got
pay
it.
in Indian rupees, it will take more time. And then after this, it came. They came pager, and then cell phone. The size of the cell phone was this much. And then it means the getting a connection with a cell phone is just going to a grocery shop. Even if you ask your children, they will laugh at us that if you want to have a telephone connection, why do you wait so much? So I think possibly nobody thought, and the type of changes what has happened in the computers, nobody thought. In 1992, the first computer which I used, that was PC-286, which had even zero memory and zero hard disk. There were only two disk drive of the size 512 kilobyte. Then it came to 1.4 MB. I was very happy. And then it came to me something like this. When I saw the first computer with the hard disk of 256 MB, I think that was the happiest day of my life.
Yeah, that's right. That's right, sir. Right. So it is not wrongly to say that the data science is an extended version of the earlier data, but because the revolution that we have faced, that we are facing nowadays because of the computer generation world actually.
No, data science is still, I would say, this is based mainly on statistics because statistics is the only subject that is informing us that which of the tool has to be there. Once you, it is something like if a person goes to a doctor and and the person has got couple of complications. In case if the doctor tells only, okay, take this paracetamol, and then you will become all right. Right, but the problem is that before the patient has gone to the doctor, nobody knew that paracetamol is really going to work, or an X-ray, or an this MRI is going to help. So, and if you ask those people who have developed the X-ray machine and MRI, right, it took a very long time for them to develop. So, but the thing is, there's a compounder or a technician or anybody, they cannot replace the doctor. So statistics is providing us the tool, that this is the tool which is going to be used, which will give us the correct answer. But definitely how to implement it, that is become a big issue, because our computers are not capable of handling such a big data. Means, for example, even if you want to invert a matrix of 100 by 100 order, or say 1000 by 1000, no algorithm, no software can do it.
Got it, sir. Got it.
So that
Second,
is our limitation. People are still trying to work that how to get a solution. I'm not saying that get a solution don't exist, but still now we have been not working so hard to get this solution. The day we get the solution, this problem will become very simple.
yeah, sir, my second question to what you just recently said, there are certain limitations point of view, like data science. Is there any limitations corresponding to the data which we are going to process or something like that? Because every system or everything has some sort of limitations in place. So is there any limitations corresponding to the data science or machine learning or artificial intelligence kind of thing?
Means there are only limitations. That is why people are working. Today all the limitations are solved and people will go and sleep. Right. So these limitations will be at every step. So in fact, okay, I will try to address this question as soon as I start my slides, because yeah, one slide is there, but I will try to address your question
Sure,
at that point.
sure, sir. Sure. Thank you very much, sir.
Right. Okay. So shall I continue? Okay, so
Please,
now
sir,
if you
please.
try to see here that, okay, I'm going very basic fundamental, and then my objective is not to teach you statistics. My objective is simply just to give you a basic background that how are we going to work and how are we going to think and how our statistical tools which we have, which are available in the books, possibly they can be used in the data science. Well, I mean, means the sky is the limit actually, that is the truth. So the first question you have to reply to yourself, that why do you need descriptive statistics? So the first thing is very simple, that we want to quench the thirst for the knowledge. We want to get an answer of questions like how, why, where, who, etc., etc. Now, nobody is going to help us, so we have only one option, that if we can collect the data about the relevant question and try to get the answer of the question from the collected data. For example, we as a student, whenever we want to choose a course, possibly the contents are important, but beside those things, there are some other aspect, that how is the teacher, how is the grading scheme, and how easy is the teacher in giving more marks or good grades, right? Without understanding that the grades are earned, not given. But we try to do all those things, and finally we just want to know whether I have to take this course or not, and by taking this course, will I get a good grade or not? So now the only thing is this: student tries to get the information about the teacher from their senior past student, and then they try to answer the question whether they have to take the question or not. So the one thing is this: all of us, they are very good data scientists, because we are trying to get the answers on the basis of collected data. Right. So this descriptive statistics is the starting point of knowledge discovery on the basis of data. As soon as we get the data, we start finding out something from it. And actually, data has lots of information, but the problem is this: data cannot speak, data cannot listen, data cannot hear. So it is as such deaf and dumb. But being deaf and dumb is not a problem. Right, because those people who have some problem in hearing or listening, there are some special languages which can be used, and by communicating through those languages, they can very easily understand the language. So data also has its own language, just like a sign language. And statistics is the language of data, which it tells us that whatever are the interpretation, whatever are the values, how they have to be interpreted. Just like reading an ECG report, X-ray, or say MRI report. But remember one thing: statistics cannot do miracles. Statistics is just trying to read the information which is conveyed and hidden inside the data. Statistics cannot change the process. And statistics gives you the correct information only by scientifically extracting the information from the data. That's all. Right. So when we are trying to come to the application of statistics on our data, then there are two options and two possibilities in each of the case. The data can be correct, the data can be wrong, the statistical tool that we are going to apply, that can be correct or that can be wrong. So now in case if we are trying to use the wrong statistical tool on wrong data, then yeah, I mean, so there is no problem, right? And the decision is going to be incorrect. In case if you are trying to use the wrong statistical tool on the correct data, then even we are going to get an incorrect outcome, right? And similarly, if you are trying to use the correct statistical tool on the wrong data, even then you are going to get a wrong decision. So the only option where you are trying to get the correct decision is that you try to use the correct statistical tool on correct data. And that is the biggest challenge in decision sciences. Right. So, for example, statistics helps us. Statistics is the language of data. It does all jobs. For example, it will do the forecasting, but forecasting is not like the astrologer parrots that you pick up a chit and then try to determine the future of this of the human being. So the rule is here very simple: garbage in, garbage out. Means if you put the wrong tool or wrong data, you're not going to get the correct outcome. And remember one thing, statistics cannot do everything in no time, right? People come to us, okay, tomorrow I have to submit my thesis. Can you please do this analysis? I say, yeah, please, means I'm not that much capable. Right. So whenever you are trying to do something, the tools have to be developed because the tools are available in statistics, but they are for a particular job. And whenever you are trying to do a job, all the tools have to be combined, and then there comes some issues which need to be solved. Right. So now when we come to the aspect of descriptive statistics, that how it is going to use us to draw different types of conclusion, then we have two types of tools. One is graphical tool, another is analytical tool. For our graphics, you know that there are different types of plots, 2-dimensional, 3-dimensional, scatter diagram, pie diagram, histogram, etc. Right. There is a one say, I will not use the proper name, but I will say that people try to think that okay, more number of plots in our analysis better is the statistical analysis. What is your opinion? Means I'm sure that means at least I get many students who are coming from outside IIT and they come to us and they try to say that they want to do this thing. And they simply have, sir, I want to plot this. I said, why? My teacher had told me. And they have a myth, they have a actually feeling that if you try to put more number of graphics in their thesis, the thesis will become better. My question to all the students and all the teachers who are advocating this phenomena is simply that when they go to a doctor, if the doctor is giving them all sorts of medicine for the pain in the head, for the pain in the stomach, for the pain in the leg, for the pain in the eyes, ear, nose, etc., will they be happy? I mean, the person has got the pain somewhere in the body. The doctor has to find it out and then give the medicine for the pain only for that part of the body, not to the entire body. So at that moment, they will say the doctor is not good. But when they try to do the same thing themselves, they don't understand this thing. So for me, this is only a wrong thing. This is only a myth thing. You have to know that which statistical tool, which graphical tool is going to give us the correct information in the under the given circumstances. Now, when you try to come to this analytical part, there are several aspects: central tendency, variation, structure of data, relationship in the data, and there are many more. And now my experience with couple of real project, I can see that there is no limit. Sky is the limit to think what you really can do. And the simple tools even they can work very well. Believe me, the use of simple arithmetic mean, standard deviation, this bar plot, histogram, that is giving us so much of information for some common question that I don't believe that you need to go for any high dimensional tool. The implementation of those tools has become difficult because nowadays what people are trying to expect from us that data generating process is automated. The data should be cleaned automatically. The data should be given as an input automatically, and the results and the processing is done automatically, and the outcome is also displayed on some website in a live mode automatically. So that is why these things are coming. But I have seen that at least for the common questions, the the measures like mean, median, mode, etc., and the measures of variation like variance, standard deviation, standard error, etc. And for the structure of data, symmetricity, skewness, kurtosis, and for relationship, different types of correlation, coefficient, etc., regression analysis, they are still giving us the good outcome. The next question comes in a real analysis. Which one should you use? The graphical tools or say analytical tool? I will say use both. You have to just see what is giving you the best information and what combination of them can give the best information. Try to use this. The analytical tools will give us the information in a quantitative way, and the graphical tools will give us an idea in a visualized framework. For example, looking at a smiley, we get a lot of information for which we have to write couple of sentences to explain it. Right, so both the approaches, graphical or say analytics, they work together and they are inseparable. When we are trying to think about a problem in the data science, all the things are working in an interconnected process, and variation does exist in all the process. Now, understanding and reducing the variations and the variation, particularly in the decisions, that is the key to success in data science. Right. So what are we doing in statistics? We are simply trying to collect the observation. We are trying to analyze them. We are trying different types of inferences from the data. And we are trying to turn the information contained into the data into a decision-making process. And this is the role of statistics. Right. But the main thing is proper interpretation of statistical inference is very important. The data generating process can be non-deterministic or say random, but in general, in decision size, most of the data is random, means there is some variation is there. Now, whenever we are trying to use any of the statistical tool in data sciences, this is very important that we should have a sample which is drawn randomly. Why this random sampling is important? Because whenever we are trying to develop a tool, or whenever we are trying to say that this tool is good or bad, we are trying to judge the properties based on some basic assumptions. And one of the basic assumptions in most of the cases is that the observations are drawn say randomly. That means the probability of collection of any observations is the same. They are independent. They are identically distributed. So in case if this option is violated, I think means after that the whole track is going to be wrong. And the outcome of the random sampling is something, it avoids the bias, statistical estimation error, sampling error, etc. So now for the data collection, now there can be different aspect. Team of surveyors can be there. You can get the data in an automated way. And then when you are trying to collect the data, you have to take care that how you have to take care of the non-responses, missing data, etc. For example, yesterday only, means I can share an email with you in which there is someone in the Telangana district. She is trying to do a project on some vehicle identification number, and those numbers are given as NA. Capital N, capital A, and she is trying to use the R software to do the analysis, and R has a problem that R takes this NA as a reserved words. So NA means the data is not available. So as soon as you write NA in R, that will indicate that the data is not available. And now in case if you try to give a variable or observation some name NA, then it will go. It is going to create a problem. So that's a very good example I got yesterday, that one has to be very careful when trying to analyze or when trying to collect the data. Right. Okay. So whenever you are trying to sample the data, variability in the population and the cost of the sampling, these are the two important aspects that you have to keep in mind. But the problem is that the size of the sample is directly proportional to cost. That means if you try to increase the sample size, the cost will increase, but the variability will decrease. So, but we want to strike a balance so that both these aspects are satisfied simultaneously. Now, here, Vivekji, possibly I can give the answer of your question that you raised, that whenever we are trying to collect the data, so we have two options. The data can be primary data or a secondary data. I mean, primary data means the person is trying to collect the data himself or herself, and secondary data means somebody has collected the data and we are simply trying to use the take a sample or use that data directly. Now, when we are trying to work on the data, then there are two types of variable on which the data can be collected, which is quantitative data and qualitative data. Quantitative data means the data can be measured or the values can be measured on a numerical scale. For example, I say height, weight, diameter of a tumor, etc. Right. Similarly, this qualitative data or say categorical data in which the data cannot be measured in a quantitative way, but that is just observed. If I say gender, so that is going to be the say either male or female, the stage of the tumor, that is first stage, second stage, third stage, etc. So we try to divide this data into the category, but if I say male equal to 1 and female equal to 2 in the category, it does not mean that the female is twice of the male, right? So then we, or the second option is we are trying to take the data in terms of male, female, and but we need to convert this male, female into some quantitative way so that statistical analysis can be done over this. Right. So now we have this type of data. And similarly, if we are going for discrete data means the numbers are going to be representing the measurable quantities such as counts. For example, here this number of students in a class, that is going to be numbers, and 30, 40, 50, that cannot be 40.5. So in this case, the magnitude is important, and the discrete data takes on a specified value that differ by some fixed amount. Say how many people have been diagnosed with the breast cancer, the possible outcome can be 0, 1, 2, 3, etc. That number cannot be 2.2. And similarly, we have here continuous data, the numbers that represent the measurable quantities taking on any values in some range. And in this case also magnitude is important. For example, if I say height of the student can be 145 centimeter, 146 centimeter, but it also can be 145.5 centimeter or 145.51 centimeter and so on. So and the difference between the two values can be arbitrarily very small. The discreteness of measurement is only limited by measuring device that we are unable to observe the values in the form of an interval, but we are observing the continuous data as which is looking like a discrete data, but this is only a conceptual part where you have to decide whether the data is discrete or continuous. Why? Because your statistical tools are going to be dependent on that one. But before I explain you, let me try to first show you that even the categorical data can be divided into a couple of categories: nominal data, ordinal data. For example, in case if the categories are not ordered, like as if I say male equal to 1 and female equal to, there is no ordering. So and the magnitude or the value is not also important, like as 1 or 2. So first type of data is the nominal data. Or for example, if you are trying to divide it into only two categories, then it is called the dichotomous data or the binary data. But definitely these categories can be more than two also. And when you are trying to also consider the order of the data, that means if I say somebody has got first rank, second rank, third rank, fourth rank, so the order is also important. So in this case, the data is called say ordinal data. Now I come to your question, Vivekji, that what are the limitations? You see, people are blindly closing their eyes. They are not thinking about this structure of data, and they are trying to use all statistical tools at all the places. This is absolutely wrong in the sense, because in the statistics, the tools have been developed based on the nature of the data, and every tool will have some limitation that this tool can be used on the quantitative data, this can be used on a qualitative data, this can be used on discrete random variable, this can be used on continuous random variable, and so on. Right. For example, if you say when you are trying to do the categorical data analysis, you have a complete books like analysis of count data, categorical data analysis, etc. Nobody wants to read those things. Nobody wants to understand those things. They simply try to use the same correlation coefficient, and they will try to find out the correlation coefficient on the count data also. Then they will be very happy that that correlation is coming out to be 0.9. And but finally, when their tool is working, they cannot find any such correlation. So that is because every tool has a limitation. Whatever you say, even arithmetic mean has a limitation, median has a limitation. Forget about any high tool. And then whenever you are trying to apply the tool, first you have to go through with the limitation, that what are the conditions under which the rules can be used, and then you try to use them. And that is true for all of us. Means I know little bit of statistics, but I don't know anything about history or geography. So if you want to ask me any question about say statistics, possibly I can answer it, but for history and geography, I don't satisfy the assumptions, or I have this limitation. Right. So that is why whenever you are trying to answer any question, try to see the nature of the data and try to see whether the statistical tool is applicable over there or not. Right. So, Abhijit,
Thank you, sir.
have you got your answer that this is the
Yes.
limitation, and limitation can be at every place actually?
Yeah, that's
Right. So now in case if you try to see here, we have, okay, I'm just going to give you a very brief background just to give you a confidence that, well, you can do it. That's all. Right. So whenever you are getting data, there are different types of variable. Right. And usually we are interested in finding out the central tendency of the data. Means if I say, means I don't know my participant at this moment, I cannot see anyone, but I believe that there are going to be some students, and even to the faculty also, that we also were a student some time back. Do you remember that when we were entering into our homes after getting the marks in the examination at school, what used to happen? My mom will simply ask me how many marks you have got, right? So now my first question will be, okay, her first question is how many marks you have got, but my first answer will be the class average is 70%, and I have got 65 marks. Right. So I was simply trying to convey that, okay, that this is the class average. That means most of the people have got the marks only around this number. So I have not done that bad. So this is the simple thing which I have used in my personal life to say from the say my could say from the from the anger of my mom, right? So similarly, that is now really going to happen whenever you want to see about the medicine effect. You always ask that how many hours this medicine is going to affect. Right. So all this information that is hidden inside the data, and the question is now how to obtain it. For example, let me take a very simple example that what type of observations you can really draw from the measures of central tendency. For example, suppose I want to go to any of the two cities in the month of May, to Lucknow or say Srinagar in Kashmir. Now, if we know that in May, the Lucknow temperature is 35, 37, 36, 40, 38, that we try to collect the data. And in the Srinagar on the same days, the temperature was 20, 18, 17, 22, 23. Now, looking at this data, can you take a conclusion that what type of clothing are needed if you want to visit Lucknow or Srinagar? certainly, yes, you can take the decision. So once you can take the decision at your personal level, my question is, why cannot you take the decision for the data science? So my answer to you is that we all are a statistician. God has given us a component in our body which helps us in thinking statistically. The only thing is this process is so fast and we are so good that we don't know that how we have taken the decision. For example, if I ask you even in this case, that how can you take a call that you have to take a warm cloth or a cotton cloth? You will simply say, okay, means if you really try to think, you will say simply, I have taken the arithmetic mean of the temperature of both the cities, and based on that, I have taken a call that if the temperature is supposed less than, or the average temperature is less than 25 degrees, then I will take a warm clothes, or otherwise I will take a cotton cloth. So now the same thing you can do at other places also, because this is a natural human tendency to compile the information in terms of average, right? So whatever are the statistical concept, they are referring to the average, they are pertaining to the central tendency of the data, and there can be different measures like arithmetic mean, geometric mean, harmonic mean, median, quartiles, mode, etc. Right. So in the case of your data science particularly, I feel that mean and quartiles are going to play a very important role, even median sometime, but median doesn't make much difference, because the difference between mean and median is that mean is affected by the extreme values, large, and the median is not that much affected. But when you are trying to deal with say millions and billions of observations, well, you cannot avoid the extreme observations, and the number of observations are so large that even the small variation there uh, will not affect the extreme observation, right? So you know that when you are trying to do with the arithmetic mean, it is defined as the simply summation xi upon 1 upon n, and where your x1, x2, xn are some numerical values that you have observed as a data. So this definition is known to all of you. So there is no issue. I just wanted to convey that what I personally have realized, that arithmetic mean plays a very important role, and there are reasons that why it is going to give us a good value. That reason is connected with the normal distribution, central limit theorem, and the uniformly minimum variance and bias estimator. So, well, this is what a place, or we don't have that much of time so that I can give you all these concepts. But surely I can assure you, among all those different types of measures, this arithmetic mean is going to give you a reasonably dependable value, right? Second thing is this, there are some partitioning values that we want to see that how many values are below or above these quantities. So these partition values can be median, quartiles, decile, percentiles, etc. Right. So median is the value which divides the total observation into two parts. So that we know that that 50% observations will be below median, and 50% of the observations are above the median. And median is better average than arithmetic mean in case if you have lots of extreme observations, right? Then it is going to better. And in an ungrouped data, it is only the middlemost value that you try to arrange the observation in an increasing order, and whatever is the middle value that you try to consider. Right. Similarly, we have here more partitions, as median is trying to divide the entire data into two parts. Similarly, we can divide them into four parts, and those partitions are called as quartiles. Right. So the first quartile will contain to 25% of the observation. Next, second quartile will contain 50% of the observation. Similarly, third and fourth quartiles contains 75 and 100% of the observations. Right. So, and similarly, if you try to divide them into 10 equal part, then they are called as decile. Right. Now, and if you try to divide them into 100 equal parts, then it is called a percentile. Right. Now, I will means I cannot ask you, but you try to think and try to answer yourself. Have you ever used this percentile somewhere in your school and colleges days? Remember one thing, there is the percentage and percentile. These are two different things. Right, now I give you here a very simple example from where you can get an idea that under what type of conditions you are going to use this percentile or decile or quartiles, anything, these types of partitioning values. Have you ever heard that there are some boards, means they are class 12 board. Sometimes we hear that, okay, this board gives us marks very easily. The marking is easy, and in this board it is difficult to get the marks. I'm sure that you all have heard these types of statements. Now, suppose you are sitting in the admission process, means for your college, you have to select the students, and students are coming from different types of colleges, which are controlled by different types of boards. Now, there are two students. One student has got 70% marks, and say another student has got just 40% marks from two different boards. Can you really compare their marks and can say that 70% is higher than 40%, or the students having 70% marks is better than the student who is having 40% marks? Do you really think is it going to happen? Certainly not. And if you are doing it, I'm sure that you have to convince yourself that you are making lots of mistake and you spoil the career of many students. You just cannot compare 40% and 70% marks. For example, if the 40% marks are from that board, which is believed that it is giving a sort of hard marking, so and the 70% might be from that board, which is doing a loose marking. So it is possible that the student who is getting 40% marks will be better student than the student who is getting the 70% marks. But the question is now how to solve this problem. Right, getting a solution in life is more important than creating a problem. So one solution is that instead of comparing their absolute marks in terms of their percentage, what we can do, we can compare their percentiles. Right. And anyone of you who has appeared in the examination of entrance examination of JEE, that is JEE Advanced, right, there is a condition that a student who has qualified the JEE Main will be allowed to appear in JEE Advanced if that student has got more than say 75 percentile marks in the respective board. What's that? So now what are we trying to do? We are trying to take all the marks of the student who have appeared in say board 1 and board 2. And now we are trying to take the minimum and maximum marks of both the boards, and then the range between between minimum and maximum marks, that is going to be partitioned into 100 equal parts. Right. So and then so it is possible that if 50% is the highest marks that are obtained by the student in the board 1, and whereas there may be 95% marks as the highest marks which the student has obtained, and similarly will be the minimum marks. So now the marks are going to be compared only with respect to the minimum and maximum value, and then we try to create 100 parts of that range, and then we try to see what is the mark at 75 percentile. And then we try to say, okay, for this board, the 75th percentile is suppose coming at 30 marks. And for the board which was trying to give the loose marking, that percentile mark is coming at suppose 90%. So it is possible that the student who has got 90% marks in the board where the marking was lenient will be eligible, whereas the student who has got just 30% marks in the board which was given a hard marking will also be eligible. So that is the basic idea of this percentile. So in data science, you are getting large amount of data. For example, you can imagine the data what is there in the, let's say, Amazon, Myntra, etc. Hundreds and thousands of people are trying to do shopping. They are entering through their login, and then they are trying to give the data to Amazon and Myntra. Right. So these types of conclusions will can be obtained through percentile. Similarly, for the mode, well, this is just for the information. You are not going to use it much, but still it is useful, I thought. So mode is the value of the variable for which the frequency of the variable is the maximum. So if there are 5 values, and suppose and we try to see that how many times they are occurring, then we try to see which is the value which is occurring the most, and that is called as the modal value. For example, means if you go to a juice shop, that person wants to ask you that what type of fruit juice he should keep, that is which is most sellable. Right. So in case of the people are preferring, say, orange juice, possibly he will try to put more orange juice. So we try to collect the data and we try to ask the choice of the people. And if the number of people they are calling the orange juice to be more, then that will be the mode. Right. And similarly, in a clothing shops also, you would also like to know that what is the size of the shirt or trouser that is going to be the sold most. Right. So mode is simply the value of the variable which occurs the most frequently, and mode is not at all affected by the extreme observations. Right. And in real life, the distribution can be unimodal, that can be bimodal, or there can be more than 2 modes also. Right. So it depends on you how you want to proceed further. Now, once you have got the idea about the central tendency, the other thing comes out that you would also like to have the idea about the variation of the data. Because if you have two data sets, it is possible that both the data sets may have the same arithmetic mean. And then our problem will be that how to choose which of the data set. And even if you're trying to use any statistical tool, suppose if the arithmetic mean is giving you the same value, then after that you have no idea that what to do. For example, if you try to see here that these are the temperature in 3 cities. In 31, the temperature in the 6 days was always 0. In the 32, it is between -15 and +15. And in 33, it is something like 11, 9, 10, 8, 12, and 10. So now in case if you try to find out the arithmetic mean of the temperature in the cities 1 and city 2, they are coming out to be 0. But by looking at the data, do you think that they are going to be the same? In the city 1, the temperature is always 0, and in the city 2, the temperature is ranging between fluctuating between -15 and +15. So there is a huge difference or huge variation in the temperature. Right. So even if you want to take a simple call that what type of clothing you have to carry in going to that city, that will vary a lot. In the city too, possibly you may have to take a strong, heavy jacket to a mild jacket, whereas in the city one you just carry only one jacket. So arithmetic mean is not sufficient to give us the information contained inside the data, whereas in the case of if you try to see in the city number 3, the arithmetic mean is coming out to be 10. Now, even if I ask you that which is the more dependable data, you will say that the city 3 has more dependable data because there is a variation. Right, but then definition a bit means definitely I have to see that which of them is varying less or more. These types of thing will come into picture. So what's really happening that by the measure of central tendency, we are trying to find out the location of the central tendency of the data, but we are not trying to measure how the values are scattered or concentrated around the mean value or any particular point in that data sets. But the question is how to capture this variation, and for that we have different types of statistical tool. But before going to those tools, let me try to ask you this question. Please try to have a look at this picture and tell me that what do you really get here? Because many times people ask me, okay, if they have got the means, can they conclude about variance? Or if they have got the information about the variance, can they conclude about the mean? So in this case, what I have done that I have taken two data sets which are indicated by green and red. So you can see here the point of concentration of both the data set is almost the same in the center of somewhere here, but their variations are different. the green points are more concentrated than the red points around the center value. Right, but they have got the same mean, but they have got the different variances. Similarly, if you try to take here this type of two data set, well, I have plotted them manually, so means I tried my best to show that they looks similar. Yeah, there can be minor variation, but ideally they are the same. But here you can see they have got two different means, say at mean 1 and mean 2. Right, so but they have got a similar variability or the same variability. Right, so in this case you have got two data set which have got a different mean, but they have got the same variability, whereas in this case you have the two data set which have got the same mean but different variability. So that is what you have to keep in mind. Many times people are badly confused with this thing, that by looking at the value of standard deviation they can try to forecast the value of sample mean. Right, so now the next question is, how are you going to measure it? So one option is this: we can measure, for example, in this case, the distance between the point of center from here or say here, and then we're trying to measure the deviation between the center point and the observed values. Right, so in case if I say suppose capital A is any point in the data set and we try to measure the distance between xi and A. Right, so this deviation can be measured by this, say here di. So now, well, we can say that if di is positive, that means the deviations are positive. If xi is less than a, that means the deviations are negative, and if xi are equal to a, then the deviations are 0. Right, for example, if the arithmetic mean is 5 and your all observations are 5, 5, 5, 5, 5, the deviations are going to be 0. Right, so now the thing is this: these are the individual deviation, but we are interested in the deviation of the entire sample. So one option is this: we can take the arithmetic mean of all the deviations, but definitely some deviations in real data are going to be positive, some are going to be negative. So when you try to take the arithmetic mean, possibly that mean is going to be close to 0, and that would possibly indicate that there is no variation. But do you really think that that there is no variation? The variation is actually there. So now the problem is coming because of the sign of the deviations. So now what we have to do here, I have to make this quantity such that it is independent of the sign of the variation. So now in mathematics, I have here two options to get this to solve this problem. Either we can take the absolute value of the deviation, or we can square it and then we try to find out the deviation. So in case if you try to take the absolute value, then I can simply take the absolute value of the deviations and find out their arithmetic mean. Right, and then in that case, this is defined as absolute mean deviation. Right, and the absolute mean deviation is defined around the point A, and this is going to take the minimum value when A is equal to here median. And this is also trying to measure the spread or scatteredness of the data around the central point of this thing. Right, and now how are you going to take the decision? For example, now I will say if I have two data set, I will try to compute the mean deviation, and whosoever mean deviation is more, I will say that that data has got higher variability. Right, as simple as that. Now, in case if instead of taking the absolute value, if I try to take the deviation in terms of a square, and then we try to find out their arithmetic mean, then this quantity is called as, say, mean squared error, or say MSC. And this is defined with respect to here, some point here, capital A. Right, now in case if you try to take this capital A to be x bar, that you try to measure all the deviation around the arithmetic mean, then this is going to take the minimum value, and this quantity is called as variance, right? And so this variance is trying to measure how the observations are concentrated around the arithmetic mean. And if you try to take it's a positive square root, that is called as standard deviation. But you will see here for the form of the variance, usually in the software you have these two options, that this option where the divisor here is n, and in the software you will see mostly people are using when the divisor is and -1. There is a reason for this thing, because that is related to the maximum likelihood estimation and principle of least square estimation, and both these values of variance, they have got different properties in terms of unbiasedness and variability, but definitely we are not going into that part at the moment. So but if you want to convert it, you have to simply divide and multiply it by here n, and then you can convert it into the form of say 1 upon n directly from the software. Now, there are two quantities, standard deviation and standard error. So the first question I would like to address here, what is the meaning of the two? So whenever you are trying to find out the value of arithmetic mean or the variance, you are essentially trying to find out something which is existing in the population. And that value is completely unknown. So that we are trying to estimate on the basis of sample that you have obtained. Right. So now there are two things which I would like to address. The first point is this: why people try to express their results in terms of standard deviation or standard error instead of variance. So whenever you are trying to get the value of the variance, you are trying to estimate it on the basis of sample. So if your sample data is collected, suppose that's on height, so your units are going to be height. So in case if you say the average value is suppose 150 centimeter, then people can understand very easily. But in case if you say that the variability is 150 centimeter square, it is difficult to understand. But if you try to express it in the same units as centimeter, people will try to grasp the value very easily. Right, so that is why it is only a matter of convenience that instead of using the variance, people try to use the standard deviation or standard error. Right, that's the very simple thing. And in the case of this decision making with respect to the variance, the same rule applies. Try to calculate the standard deviation, standard error, or the variance of the data, and whichever data has got more value, that will be said to have higher variability. Right. So higher variability and more concentration, that you have to understand the difference between the two. Right. So that is the same thing. And before I try to address the difference between standard error and standard deviation, the first question comes that if you have to choose between the variance and absolute mean deviation, that which of the this tool has to be used for measuring the variability, then I would say that in case if your data has too many outliers, some extreme value, then median is less affected by these outliers in comparison to the arithmetic mean. So in this case, absolute mean deviation is a preferable option over the variance. And variance has its own advantages that from the statistical point of view, from the mathematical point of view, we can handle it more easily. Right. Now I try to address a very...
Hello.
Yes.
I think Miss Sunita has some question.
Okay, yeah, actually I cannot see on the screen. I'm just looking only on my this slide.
Right,
Yes,
right,
sure.
right. That's why I'm.
Yeah, sure.
Yes, Miss Sunita, do you have any question? You have raised your hand actually. Maybe that is by mistake. You carry on,
Good. Yeah, I'm actually saved because there is always a risk whether I can reply the question or not.
please.
Right, okay. So if you try to see here, what is the difference between the standard deviation and standard error? You see, whenever you are trying to find out the variance, that is around the mean. And mean is the value in the population that is unknown to us. So when we are trying to compute the standard deviation, that is defined as the positive square root of the variance, and it is defined here like this: 1 upon capital N. Capital N is the population size, and mu is the value in the population that is unknown to us. So this basically this mu is unknown to us, and when we have to know the value of mean, why should I do statistics? Because statistics is primarily helping us that the same conclusion can be drawn on the basis of sample of data. So now what we do here, that since we cannot estimate here the mean, or we don't know the population size, so what we try to do, we try to estimate them, or we try to replace them with their sample values. For example, instead of population mean, I can use here sample mean. And instead of here population size, I can use here the sample size. So now we have here this quantity like this one upon small n, that is the sample size, summation xi minus x bar whole square. So now this quantity can be very easily computed on the basis of given sample of data. So whenever we are trying to take the positive square root of the estimator of variance, or in simple words, the variance can be estimated on the basis of given sample of data. It is not depending on any of the population value. In a simple language, we call it as standard error. So the standard deviation will depend on the population value that you cannot estimate, but you are actually using standard error, which is dependent only on the sample of data. Right, but people practically don't differentiate between the two definitions. That is up to them, that I cannot control. Now, similarly, now if you have got the idea about the mean and variation, sometimes you have heard about the statements. Okay, somebody will say, okay, means my friend is working in US and he is getting a salary of say 1 lakh rupees or 1.5 lakhs rupees every month, whereas in India I am getting only say 40,000 or 50,000 rupees. And you become very happy and you want to migrate to US as soon as possible so that you can get a better salary. But then my question is, can you really compare their salaries? It is not. This is a wrong way of comparison. Nowadays, you will see that every day in the news, there is a news about the placement of different institution. Okay, this student has got the package of 1 crore or 2 crore. It is not actually, because those jobs are not in this country. So you cannot compare them, their salaries as says my friend who is getting a salary of say 1.5 lakhs in US, that is equivalent to saying that he or she is getting say nearly $2,000. And here I am getting here 50,000 rupees. That is 25% of the salary, but it is not comparable because in US you have to pay the house rent also in terms of US dollars, and possibly say $1,200 will go into house rent if you have a housing in say this New York type of city. For example, if you are staying in a city like Lucknow, possibly I'm sure that you can get a 2 BHK or 3 BHK in say 20 to 25,000 rupees, but in and New York, getting a 2 BHK or 3 BHK, I think possibly you have to work for your entire life. Right, it is just like getting the house rent in Bombay and a city like Lucknow or say Kanpur. So in order to compare, to make comparison in such a cases, which is usually the case in data science, because you want to measure different types of quantities, you want to compare the shopping of clothing and the shopping of utensils. So this coefficient of variation concepts help us, and this is a very simple thing. Try to compute the sample means of both the data set, try to compute the standard error, and then try to compute their coefficient of variation as standard deviation divided by arithmetic mean. And obviously, yeah, standard deviation is greater than 0, so we have to assume that sample mean is also greater than 0. Otherwise, you can take its magnitude and try to use this coefficient of variation to make a logical comparison instead of only arithmetic mean or the variance. And the data with a higher coefficient of variation is said to be more variable than the other one. Right. Now, the other aspect is about normal distribution, and I will try to show you that how it is going to help you in the statistical inference part. But I think this is 11:20 almost, so means I would prefer if you have any questions, and I will be happy to answer them. And after that, means I will try to start this topic in the next session so that we have a logical ending also. Otherwise, this will be hanging between the two. Right, so I would request if you have any questions, you are please feel free to ask.
This is Tapas Mitra here. Yeah. I have one question regarding standard error. So if you can explain that standard error once more, I'm not very clear as yet.
You see, when you are trying to define the variance.
Right.
Variance is defined over the entire population.
Correct.
Right. Now, and then variance is defined as, say, for example, 1 upon the population size, summation over the population size, xi minus mean whole square. Now, this mean is for the entire population.
That's correct.
Right. Now, the fact is this, we don't know the value of the mean of the population.
Okay.
So how can you estimate it?
Okay.
Right. So you just cannot estimate it.
Okay.
So, and then what we try to do, we try to replace the population value by the sample values.
Right. Okay.
And then we try to say that, okay, this is my standard deviation.
Right.
But that is actually standard deviation, which is based on the sample value. So it is not a standard deviation, but this is called as standard error. And from the statistical point of view, if you ask me, the statistical properties of the variance and the variance that is computed on the basis of sample, these are two different things. They have different types of properties.
Right.
So that is why we differentiate. And secondly, you have to understand one very important thing, which nobody actually bothers about it. You wanted to estimate the variance on the basis of given sample of data, but you are trying to find out the square root of the variance. So from the statistical point of view, the statistical properties of the variance and its square root, these are two different quantities.
Okay.
So that is why from the statistical point of view, we always differentiate between the standard deviation and standard error. And officially speaking, legally speaking, the standard error is defined as the positive square root of the variance of estimate of variance of the estimator. Means you try to take your estimator by which you are trying to find out the variability. Suppose if I'm trying to find out the population mean by sample mean. So sample mean have some variability. So we have to find out the value of the variance of the sample mean.
Right.
And then I have to replace the unknown quantities by the sample values.
Right.
And then I have to take the positive square root. So this quantity, for example, will be simply square root of, say, s square upon n, whereas the you wanted to estimate sigma square upon n. So there are four things. One is sigma square upon n. Another is its estimated value, means s square upon n. And third thing is, and third and four are the positive square root of both the quantities. These four are altogether different things.
Right.
So they have got a statistical property, but in practice, people don't hurry that much. But it is important that if I am making a mistake, if I know, then it is good.
Okay. So the standard error that you're saying is basically coming out from the sample.
Yes. Yes.
Exactly.
Exactly.
So it is the same computation methodology which is used in population.
No. That is itself a big challenge for us in statistics to find a good estimator for the variance under different types of condition. But honestly speaking, Tapas, we are not so capable, we are not so good. So we are trying to approximate it by something. But ideally means every situation will have a different formula for computing the standard error.
All right. Okay. Thank you very much.
Hello.
Yes.
Sir, I am Dr. Pankaj Goswami from MIT Institute of Information Technology. Sir, I want to ask one question related to this squared error. So I just want to know the application areas of squared error and why we preferred in this.
Yeah. So in fact, you see, our objective is not really to find out squared error, but we really want to measure the variation. The variation is there in the data that we actually can see, we can feel. But our job is how should we do it, or what type of mathematical tool should we employ so that we get the quantified information on the variability. So the biggest challenge is that we have to quantify it, and for quantifying it, people can express it in different ways. So I have taken here two possible ways. For example, I am trying to take the absolute deviation between the value and the observation, and then I'm trying to take the squared value of the deviation. So these are two different measures which are trying to measure the same variation that is existing in the population. Okay. The only thing is this, and then yeah, it's not only these two. There are many such variations which are simply trying to capture the variation inside the data in a quantified way. So when we are trying to use the absolute deviation and square deviation, the difference is that that actually, if you ask me statistically, if I say which function is easier to differentiate, obviously square error function is very easy to differentiate. It is very easy to optimize, whereas if you are dealing with the absolute function, it is very difficult to optimize it. Right, you cannot find out good value, unique value to teach in the class. So whenever we are trying to find work with the absolute value, this is more useful when you have extreme data because it will take care of it. But if you have a because square error function, then this extreme value are going to affect it a lot.
Okay. This takes the effectiveness of the decision.
Yes. And then there is no rule that this is going to be better than this or that. It all depends on the situation. And I always say when you are trying to deal in real data, means what's wrong if you try to apply all the tools over there, and because it is just like if a student is good, either I try to take a Viva or a written exam or a practical exam, he will always do good.
Okay.
He or she will always do good. So if your data has variation, that even if you try to find out absolute deviation, variance, etc., they are trying to give you different types of information. For example, if you ask me, suppose I get a data that is unknown to us, and suppose I try to find out the value of absolute deviation as well as standard error or say variance. Now, in case if I say that the difference between the two values is very huge, the first reaction I will have that possibly there are lots of extreme values. So different types of conclusions can be drawn by looking these values.
So shall we proceed for both of the variants?
Yes. When we go to a doctor and we complain, the doctor thinks in a multivariate direction that if we simply say that the person has got a pain in the stomach, the doctor will think in a different way that there can be a tumor, there can be a simple stomach ache, or there can be something else. But finally, he will start thinking from that point, and then he will try to observe more things, and then he will try to finally conclude at one point.
Okay, thank you, sir.
Who stops you? Right? The fact is this: who stops you in applying those tools? And they have zero cost. You simply have to write a one-line program.
So, okay, thank you, sir.
Thank you.
Any other query, participants? I think you've explained all topics very nicely. So we can take a pause. This is a half an hour break. We'll meet again at 12 o'clock.
Yeah, sure. So I will just remain online.
Yes.
I will just remain online, and I will show my face and my voice at 12 o'clock.
Right.
Okay. Thank you.
And the participants also, you are advised to be online. Do not log out because otherwise you will face login problems. But we will join back at 12 o'clock for the continuation of this session.